can be captured on YouTube. Okay. So the first thing I have, I've got the amplitude. That's 2. And in case you don't remember, the formula for the amplitude is just the absolute value of A. In other words, the amplitude is going to come from some sort of vertical stretch. And that's what this A value is right here. So basically what I'm doing here is I'm going to take my formula and I'm going to solve for whatever the letter is. And then I'm going to plug that letter into my function. So what is A? If it's got an absolute value of 2?
2.
Yeah, it's 2. I mean, technically it could be negative 2 also. But let's just call it 2. Okay, so A is going to be 2. So there's one of my numbers right there. So I've got 2 times cosine of some other stuff. Okay. Now I've got to find B. So B is B represents what kind of transformation? What type of transformation would that be? Yeah, horizontal, stretch or shifts. B plays the accordion. So, actually, I play the accordion when I talk about B. So, how do I find that? Well, that horizontal stretch is going to affect the period or the frequency. If you weren't here last time, where the period is basically like the length of a wave. The wavelength, you might call it. Okay, so normally the period for excuse me. Normally the period for a sine or cosine wave is 2 pi. But then we have this horizontal stretch or shrink, and because it's happening to the x value, it does the opposite of what it says. So instead of multiplying that period by b, we actually divide it by b. Okay, so I can use this to solve for b, because I know what the actual value of the period is, because it says it up here. So the period should be pi. So I'm going to say pi equals 2 pi over b. And again, I'm just going to assume that b is positive, because we're taking the absolute value. Technically, b could be negative as well. That would just be a reflection, but we don't really, from these parameters, it doesn't really matter. It could be positive or negative. Okay, so how would I solve for b if this is my equation? How could I find b? Help me get this equation solving started. Okay, so multiply the b over to this side, and then divide the pi over to that side. Yeah. So b would equal 2 pi divided by pi. Okay, everybody follow that. Multiply the b over to the left, and then divide the pi over to the right. They basically switch places. What's 2 pi divided by pi? Yeah, so b is just 2. In other words, instead of having my standard period of 2 pi, in other words, it takes 2 pi for all the sine and cosine values to start repeating. Here, it's only going to take pi. That means it's been horizontally shrunk. It's been cut in half. Okay, so we've got a 2 there. So our waves are half as long. They're horizontally shrunk by 2. All right. Now I really don't need to use the frequency. I could use the frequency to do the exact same thing, because the frequency is just the period upside down. It's b over 2 pi. So if I solve this equation, I set it equal to 1 over pi. I'm going to get the same answer. I'm going to get 2 for b. So the period and the frequency are basically giving us the same information, just in a different form. To find c, which of these parameters do I need to look at? And by the way, C would be what kind of transformation? Yeah, left to right shift. So which one of these parameters does that? Yeah, the phase shift. It's just a horizontal shift. So that's going to give me C. So the phase shift, our formula for that was negative C. And by the way, if you weren't here yesterday, all of these formulas are on this paper up here. So in other words, negative C is equal to 5. So there's my equation. Negative C is equal to 5. So what is C equal to? Negative 5. So that's going to go in.
Wait, how for F did you end up getting just 2?
Well, here, let me put this in. So that negative 5 would be in for C. So it's going to be x minus 5. In other words, a phase shift to the right by 5. So on F, so if I wanted to solve for B, if I set up this equation instead of this one, I would multiply both sides. To get B by itself, I'd multiply both sides by 2 pi. All right, so I get B, so I multiply by 2 pi over here, equals 2 pi divided by pi, like that.
Okay.
Just by multiplying the 2 pi over. And it would multiply on top of it. Which is, of course, 2 again. So same thing either way. You can use frequency, you can use period to figure B out. Because really they're just the same thing upside down. All right, we got a phase shift, we got A, B, and C. We need to find D to get our equation. So what kind of transformation would D be? Yeah, a vertical shift of some sort, up or down. So which of these parameters would tell us about the vertical shift? Yeah, the center line. So in other words, what is the wave centered around? The standard sine wave is centered around 0. So it goes above 0, then below 0, then above 0, then below 0. So this sine wave is centered at negative 1 instead of 0. So in other words, the center of the wave is getting shifted down 1. So the center, what I called yesterday the center line, so the center is always at y equals d. So it would be at y equals 0 unless there's a vertical shift, then it's going to be at y equals that number. So if my center line is y equals negative 1, then what is my value for d? Negative 1. So I'm going to have plus negative 1, or I might rewrite that as minus 1.
Wait, so why did you cross out for the F? Why did you cross out the 2?
Down here?
And yeah.
So if you wanted to solve this equation for b, you would want to multiply both sides by 2 pi, right, to get the b by itself. So I would multiply that side by 2 pi to cancel it out. And then multiply the other side by 2 pi, like that. Okay. And then once I have all those blanks filled in, the A, B, C, and D, I have my equation. So there's the equation of my cosine function. And in general, this is a more realistic situation that you would find yourself in, having the parameters for a wave and trying to come up with a function so you can graph it or do otherwise analyze it, instead of having an equation for a wave and then trying to find the parameters. This is a more useful skill right here. So I want you to practice this. So try this. This time we'll take some from this worksheet right here. So try these first two. Well, just try this first one. I, for some reason, didn't put numbers in here, but it's 13 through 15. So this is on that paper I passed out last week. We answered a few questions off of. It's got a bunch of graphs on it. This is on the back. So try this question right here. Same thing, same question. We'll see if we can fill in the information. Does everybody have a copy of this? It might be. There's one that's different. So that's the like where the resting position. It's usually a 0, but it's shifted at
And then this would just be plus 2.
It's going to come, so the 2 is right there.
Oh, so that's going to be plus 5.
Yeah, it'll be.
Isn't it opposite?
Right, so this is the patient, it's 5, it's a positive 5. Then the formula is
2 pi times
yeah, so the patient is negatives because it does the opposite. So the patient is 5 in the formula. That's the patient is 5. So the formula is 5 is 5.
Oh.
Problems over there. Got complications over there.
All right, let's double check on this. So most of us got this, especially the A, the C, and the D. It's really only the B that you have to think very hard about. As long as you understand just the basic setup here. So we're going to have A some number times cosine of something times x plus or minus something plus something. Okay, so basically our equation is going to look like this. This is the standard form of any equation that has transformations. We just got to fill in the A, B, C, and D. So the A comes from the amplitude. So where does that 2 go? Yeah. There's the 2. That comes from the amplitude. And I'll go ahead and fill in the C and the D because those are easy as well. C is the phase shift. That's a horizontal shift. Where would the horizontal shift go? Yeah, it's going to go right next to the x, and it's going to be the opposite sign. So the phase shift is 3. That's going to be x minus 3. And again, you can set that up as an equation if you really want to. You would have 3 equals negative c, which gives you c equals negative 3. And then the center, y equals d. So that d, which is the vertical shift, is going to be a plus 10. So those 3 parameters are really easy to fill in. Basically, you can just plug them straight into the equation. The only one you have to spend much time thinking about, I'm still recording. Oh well.
Wait, why did you put cosine?
If you go back and watch this later, there's like 5 minutes you can skip. That's a good question. Why did I put cosine? I'm not sure. Let's just pretend that I put sine the whole time. You could do the same thing for, well, tangent doesn't make a wave, so these wouldn't make sense. But you could do the same thing for cosine. But I did specifically say sine up here, so thank you. Okay, so how do I find B? So B is a horizontal stretch or shift. So how did you get that? Yeah, so P is 2 pi divided by B. And it's the absolute value of B, but when we're solving for B, we're just going to ignore that. And so okay, so P is good. P is pi.
Switch B and pi, and then you just cancel out the pi and it's 2.
Right. And so this is exactly the same as the way we solved this equation on the warm-up. So pi is equal to 2 pi over B. Multiply both sides by b, divide both sides by pi, and the b and the pi basically switch places. So b is equal to 2 pi divided by pi, which reduces to 2. And that 2 is going to go in our horizontal stretch or shrink spot. And is that a horizontal stretch or a horizontal shrink? Yeah, it's a horizontal shrink. Okay. So let's try one more. And let's go back and talk about the Ferris wheel. Did we talk about the Ferris wheel yesterday? No. Oh. Good. Then we'll do it now. Okay, so sometime last week, last Thursday or Friday, we virtually rode what was formerly the world's largest Ferris wheel, but now isn't anymore because there's a bigger one in Las Vegas. There's a Ferris wheel arms race going on. I don't know if you've noticed, but every couple of years somebody builds an even bigger Ferris wheel, like 5 feet taller, so that people will flock to their city.
So it's no longer buildings, now it's Ferris wheels.
Exactly. So as soon as I told you what the highest one in the world was, somebody else would be like, oh, I'm going to build a bigger one, and I'm going to have the highest one. So we're just going to stick with the Singapore Flyer. It was the highest one about 5 years ago. And if you recall, or even if you don't, it looks like this. Ferris wheels are round. And so we tried to figure out how your height changes as you ride the Ferris wheel. Hint, it goes up and then it comes back down. And if you rode it again, it goes back up and it comes back down. So it makes a wave, basically. And we came up with an equation for that wave. The equation was 90 minus 75 times cosine of the angle. That was our equation. Okay, so that happened last week. So I want to find the parameters of this equation right here. And when I say the parameters, I'm talking specifically about amplitude, period, frequency, phase shift, and the center line. So I want to find the parameters for this wave right here. And the reason I want to go back and look at this equation is because here the parameters have significance as far as the physical object that we were tracking. And so I want to try and make that connection. So first, let's start with the amplitude. And for those of you who weren't here yesterday, the amplitude is how tall a wave is. And that's measured from the center up. Okay. And the amplitude is going to come from the A value in this equation. So, as I'm looking at this equation, the first thing I see is a 90. So that probably means my amplitude is 90, right? No. Then everything I know is a lie. Unless you can explain why. So why isn't the 90 the amplitude?
That's your center line.
Okay, so the amplitude would actually come from what?
75.
Okay, so the amplitude is multiplied by the cosine here. That 90 is really added. So all I need to do to put this into standard form is put that 90 on the end. Make it a plus. So that's actually, yeah, like you said, the center line. And my amplitude is going to be the absolute value of negative 75, which is, yeah, regular 75. Now, I want to try and interpret this in terms of the actual physical object, the Singapore Flyer. It's a Ferris wheel. You go around in it. It's also really big. Okay, so in terms of the wave itself, the 75 means we're going 75, this was in meters, 75 meters above the center of the wave, 75 meters below the center of the wave. That's our amplitude. So what is that actually telling me about the physical object, the Singapore Flyer Ferris wheel extraordinaire? So I want to translate this number onto this physical object. What is that 75? What is the significance of it? What is it telling me about this Ferris wheel? The radius?
No,
How tall
The diameter?
What does that say?
How tall it is?
Interpret.
Am I?
how tall the wave is?
It's how tall the wave is. So what is that telling me about the Ferris wheel itself? So it's not the total height of the Ferris wheel,
Just a circle
because
from the thing.
so it's just on the circle, because that's where the wave is happening, right? So we go 75 meters above something, then we go 75 meters below something, and then 75 meters above something, and 75 meters below. So what are we going above and below on the Ferris wheel?
The middle part.
Yeah, the middle part of it, the center. So we're going 75 meters above the center and 75 meters below the center. I know.
Oh, that's.
I
wanted me to say-
didn't say you were wrong.
Oh, yeah.
I just wanted to know why. Yeah. So the radius of our Ferris wheel is 75 meters. So that's the amplitude of the wave. So if I wanted to, so if I built a bigger Ferris wheel, let's say a Ferris wheel with a radius of 100 meters, which by the way would scrape the ground, so probably not a good idea. But if I did, how would that change my function? If I increase the radius to 100 meters, what would that do to my function?
Amplitude high.
Yeah, that would increase the amplitude of my wave, right? That means I'm going further above and further below the center. So I would see the same thing on my wave. I would go further above the center, further below the center. So that's what the amplitude means in this case. So these are the kind of questions I like to ask on quizzes. Hey, 75 meters? Okay, so what? What does that have to do with this actual thing? Okay, let's get the period. So we got the amplitude, the period. Remember, the period is how long it takes you to complete one wave. That's the period. So in other words, how long does it take this function to start repeating itself? Now, we can get that from the equation. What's the formula for the period?
Absolute value of B.
Yeah, 2 pi over the absolute value of b. And what is b in this equation? That's our horizontal stretch or shrink. So if there's not a number there, what would we call b?
1.
1, yeah. It's multiplied by 1. So what's 2 pi divided by 1? Okay, so let's try and interpret this number in terms of the physical Ferris wheel.
Wait, you said period was how long it takes to.
So that's the length of one complete wave on the graph. It's the wavelength, another name for it. Of course, here it's not an actual length, it's an angle. So what is it telling us about our Ferris wheel?
How long it takes to get one somewhere?
Yeah. So one repetition in terms of our Ferris wheel, one wave, is going to be one complete rotation, right? And how much is one complete rotation? Well, it's 2 pi. So the period tells us how long it takes to make one repetition. In this case, we don't have time on our x-axis or a distance, we have angles. So one repetition is 2 pi, which is one complete circle, which makes sense for something like a Ferris wheel. You're going to start repeating sine or cosine values every time you make one complete circle. So anything that was, a circle is probably going to have that same period. Okay, what about the frequency? So how do I calculate the frequency? Absolute value of b divided by 2 pi, or in other words, just the period flipped upside down, the reciprocal of the period. So it's 1 over 2 pi. So what is this telling me? The frequency. What is that? Yeah, so the frequency on a... Yeah, basically. So the frequency on the wave tells us how many waves we have in a certain length. So the period, I think I wrote down this or something like this yesterday. The period is like the length for each wave. So the length per wave. How long is each wave? That's the period. It's the wavelength. The frequency, on the other hand, is the same basic information. It's just given in a different form. So this is the number of waves for a given length. So it's the same information as the period, it's just given upside down. The period tells us, hey, it's going to take 2 pi radians for each wave. Whereas the frequency tells us, hey, for each one wave, it's going to take you 2 pi radians. So it's the same information, just given in a different form. It's upside down.
Can you brighten your screen?
Maybe. I'll try in a second. So it's the same as the same information as the period. Let's see. Is that brighter? No.
You just come with Twitter whenever you're ready.